Hello, I'm Brian Hepkema, CIO of AtomOS. As CIO, my duties include coordinating customer support operations, quality assurance, and testing of the AtomOS operating system. Acme Fabrications is a 20-person office in which we're going to configure AtomOS to act as their internet gateway, providing firewall, quality of service, wireless connectivity, authentication, web filtering, and voice services. All of these services can be set up in a remarkably rapid fashion. Here you can see one possibility in which we may deploy AtomOS as a gateway device, which allows it to provide connectivity, firewall, routing, and QoS services on a corporate network. This diagram indicates where in the topology the device would reside in a typical configuration for a smaller scale infrastructure, as would be found in a smaller office or branch facility. So now we're going to talk about installing and configuring AtomOS. Let's go ahead and get started. I'll begin by plugging the AtomOS Quick Key into a server device configured with a dual-core Atom processor, 1 GB of RAM, a 32 GB SSD drive, and 4 network interfaces. The key will boot AtomOS and repurpose the device for use as a networking device. From a browser client connected on the LAN interface, the system can then be configured in the AtomOS GUI. In its default configuration, AtomOS configures the first Ethernet port as a LAN port. I will be connecting my notebook to that Ethernet port, which will allow me to log into the AtomOS GUI using my web browser. All configuration is performed in the GUI, which makes maintenance and remote access very simple. By default, the administrative password is admin. The first step is to repurpose the device's local hard drive, which is where runtime data will be stored. Depending upon the size of the hard drive, this process may take a few minutes. Once it's completed formatting, the device will reboot itself and be ready for additional configuration. Now that the device has rebooted, we have logged back into the GUI. The first step in this configuration wizard is to license the system by pasting my system license from AtomOS support into the licenses field. The first thing we will want to do is change the default password from admin to a stronger and more secured number and letter combination. The next step would be to configure the host name, domain, and time zone for this device. Once the password has been changed, you will be required to log in once more. Once logging in again, AtomOS will attempt to identify whether there is a live internet connection on the WAN interface, which would be on the second Ethernet port of the device, or ETH1. At this point, you were given the option to upload statistics to AtomOS's firmware servers. This allows us to gather information about installations across various systems to help us improve AtomOS. The wizard will also assist in configuring your wireless network. For wireless access point capability, we've installed an Athros-based wireless PCI card. Simply enter in the desired SSID and authentication password in the fields indicated, and the wireless device will be automatically bridged with the LAN interface and ready for use. Success! Your wireless network is now working. You should now be able to connect to your new wireless network with your wireless devices. At this point, the device is now configured for connectivity, firewall, and routing capabilities, and we can further enable and customize other services from the GUI. One of the first things we might like to customize and configure would be the QoS feature. In order to set up QoS, or quality of service, we must go to the routing category menu and select QoS Management. First, select Enable Bandwidth Management, followed by Enable Easy Setup. In order for this feature to function properly, we need to know what our bandwidth metrics are. Using a site utility such as speedtest.net will provide this information, which in our case is 20 megabit downloads and 8 megabits upload. Enter these parameters and click Save, and our configuration for QoS is complete. AtomOS features a comprehensive web filtering and traffic acceleration functionality that provides client-side protection from undesirable web traffic and internet content. In order to access this feature, we first select the Network Services category, followed by Web Filter. From this screen, we simply select Enable Filter/Accelerator and then Enable Transparent Filtering on our LAN interface, which forces all client traffic to be routed through the filtering service without the need to configure client-side browsers. We will also select a Bypass Authentication, which allows authenticated users to bypass the web filter on a temporary basis. The bypass setting is tied to the IP address of the client and times out after a configurable interval. In this case, we're going to use a bypass timeout of 10 minutes and a passcode of AtomAMPed. Once that is complete, we click on Save, and our web filter is configured. Next, we are going to further customize our filter settings by enabling a number of other features. Enabling Safe Search will configure client sessions to only perform searches of designated safe content, which is maintained by third-party search engines. We can also enable the YouTube for Schools feature, which blocks inappropriate YouTube content using educational channels access only. Virus filtering can also be enabled in this screen, which turns on the antivirus service for web content. We will also enable a few URL categories that would be deemed as inappropriate for LAN clients and users. We click on categories like so. Once complete, we again click Save, and our configuration is complete. As you can see, with just a few simple clicks, we have a full-featured web filtering service in place and configured for optimum content control and safety. The last step in setting up our instance for Acme Fabrications is to enable and configure the Voice over IP PBX feature. This feature will provide VoIP services such as auto attendant, ring groups, connection with a third-party SIP trunk provider, and individual extensions for all SIP-compliant VoIP handsets, including voicemail and voicemail to email functionality. Our first step in configuring VoIP is to enable our local SQL server for storing call data detail report, or CDR data, that will be collected once the system is live. This can be enabled in the General category under Configuration. Simply select Database Server from the left side menu, check Enable Integrated Database Server, and click Save. Next, we will navigate to the Communication Services category and select VoIP Telephony Services. We will then check Enable VoIP Telephony Services, scroll down to Enable Database Support, ensuring that the local server is selected, and then click Save. For Acme Fabrications, we will set up an initial extension by selecting the Extensions menu item and then clicking on the green plus symbol in the center. This will bring us to the extension configuration screen. There are only a few items required here. The extension number, we'll use 100. The display name, which can be the same as the extension number. The extension password. An allowed voice over IP codec. We'll use G.729A, a highly optimized and efficient codec. A peer password, which is used for SIP authentication. And we'll also enable the voicemail feature for this extension. Click Save, and our extension configuration is complete. We must also apply the changes to make them live. To provide call routing to the outside world, we will need to configure an IP trunk for the system to connect to. In most instances, a third-party SIP trunk provider subscription will need to be initiated prior to configuring this. For our purposes, we have already created an account with our service and can go ahead and create a trunk that will connect to their SIP offering. We'll give it a name, for instance, default. Make sure that the allowed VoIP codec is G.729. Enter our password for our SIP trunk provider. Enter the peer address. We want to enable register on the remote VoIP gateway on port 5060 with our provided username. We'll also want to allow incoming connections over this trunk. We can leave the peer port as it is. Enter in a default dial pattern. In this case, we can enter in the exclamation point as a wildcard and click Save. We also must apply the changes to make them live. The final step for our example will be to create outbound and inbound routes. These will connect our configured extension to our SIP trunk and provide an end-to-end voice over IP connection. On the left-hand side, we will select routing and then create an outbound route. We have to give the route a name, in this case default. We'll add a wildcard dial pattern so that all outbound calls go through this route, and then explicitly define which trunk we will be using. At this point, we can click Save and apply changes. The final step will be to create an inbound route. We'll add, as before with the outbound, give it a name, in this case default again. For caller ID rules and DID rules, we can wildcard them with the exclamation point. And we'll allow all trunks. And as a destination, we should select the extension that we configured before. Click Save and apply changes. Our voice over IP configuration is now complete. Acme Fabrications now has a gateway device configured that optimizes their bandwidth, protects their users from harmful and inappropriate content, allows wireless connectivity, provides a full-featured voice over IP PBX, and performs stateful firewall blocking, all in one device. Thank you very much for your time and interest in AtomOS. Please visit our website at www.atomamped.com for more information and in order to schedule a personal demonstration.